Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. We're a meetup group. We meet up every Tuesday afternoon and we look at Python programming and machine learning for beginners. So the emphasis is for beginners, and the benefit of these sessions is that you can ask questions live so that you can get answers, and we are very interested in your questions. It's more important that we get questions than we finish the session. So I hope I've got a few people with you. I've got a few people with me tonight. So let's get started. If you're on the YouTube webpage, you'll find a link down below that will get us started, or you can get the same link from meetup.com. So what we're going to do today, here's the link. It's a link to Colab Research, and that's a Google facility to give us a way of running Python without needing to install it on our computers. So if you scroll down and you should see that link, then you can open that link in a new window in your web browser, and you can watch the video in one window and work along in another window on the sessions in the notebook. And these notebooks are fantastic for doing Python. They're really powerful. People use them in a professional capacity, but they're also great for learning. If you want to ask questions, you can ask them on the YouTube chat, or you can also ask them in Slack, and we've put a link to how to connect to Slack. And we're on the Learning to Code channel in Beginners Python on Slack. So that's where you can ask the questions, and you can even ask questions after the session's finished, although people won't be watching it so closely then. If you see a question that you know the answer for, feel free to answer someone else's question as well, because we are a meetup group, and so we're all going to be working together. All right, so find this link to Google Colab and click on that. And that will open. You might want to right click and say open in a new window so that you can watch the video at the same time as working through the notebook. And these notebooks have a mixture of text and Python code. So all the top bit is all formatted text, and then down here you'll see Python code. But the first thing we want to do is make a copy of it so that we can make changes without it affecting anyone else. Yeah, in fact, the one that you've got the link for is a read-only copy anyway, so you can't make changes to it. So we'll click on Copy to Drive. That's a big button there if you're in read-only mode. And you'll also, if you don't have it there, then you can go to the File menu and choose Copy to Drive from there. So if we look in Save a Copy in Drive, that will do the same thing. All right, now I've got this notebook here. I'm going to share this one so that if I type something in this one, you can use that link to grab anything that I've typed during the session. So let's share that, and I'll put this link into the Google chat on YouTube, and I'll also put it on Slack. So anyone with this link can see what I've typed. And that should now be in Slack chat and also on YouTube chat. So what we're going to go through tonight is how to use interactive Python. We're going to have a bit of an introduction to coding, so writing little short programs, and they'll be looking at different things like branching and looping, and we'll also have a look at list comprehension, which is a fun way in Python for creating lists in a very short manner. All right, so challenge 1, get your software ready, and for this we can just use colab.research. I'm just I don't want to do that now. Okay, good. It looks like it's paused that. So Colab Research, that's where we are, and so that doesn't need Python installed. Alternatively, you can go to python.org, and from the downloads you can download Python 3.10, which is now out, install that on your computer. Alternatively, you can use Anaconda. If you're brand new to Python, the difference between Python and Anaconda is that Anaconda takes your normal Python and then adds a whole bunch of third-party libraries, normally the ones that are useful to people doing data science. So if that's you, you might find Anaconda an easier way to install it, because then you've got a lot of the stuff installed straight away. You don't need to install it again. If you're doing programming in Python, I like to use PyCharm. The community edition is free, and you can get that from JetBrains. That's an integrated development environment. There are other ones around like Visual Studio Code or Atom, Spider. Even the standard Python comes with one called Idle. Okay, there are many ways to write Python, and we're going to be using a thing called Jupyter Notebooks. So that's what Google Colab gives us. It gives us these Jupyter Notebooks, and they're an extension of IPython, also known as interactive Python. But you could also do all these exercises in just straight Python, and a Python version of this notebook is available at that URL in our in GitHub, and we keep them there. All right, so let's start playing with these notebooks. So how do they work? You can see there's different cells. This is a cell. You can see the border around it. That makes it a cell. Here's a cell. So that's a text cell. This is a code cell. And at any point in time, you can add another code cell or another text cell just by clicking on these buttons that pop up between any of the cells that currently exist. And that just shows where the new one will get inserted. In the code cells, if you want to type in some comments, which is just basically some notes that don't do anything, then you use this hash sign at the beginning. So I've typed in a few comments here to explain what comments do. And so these comments are telling you how to bring up the IPython help, which is typing a question mark. So you can see I've typed a question mark here. I didn't need to type any of these comments here. I could have just put the question mark. And then I need to run the cell. And you can see there's a little play button here, so you can click on that. It's one way of doing it. You can type Control Enter is another way of running the cell. I've said Shift Enter, and that's a keyboard shortcut like Control Enter, but it runs a cell and then jumps to the next cell. If you want to see what these keyboard shortcuts are, you could look in the Tools menu, and there's keyboard shortcuts, and there's a whole bunch of them there, so you can have a read through all of those. And when you get good at using Google Colab or Jupyter Notebooks, you'll start to know a lot of these keyboard shortcuts. Okay, we have a question here. What's the difference between .py and .ipynb? So py is your normal Python script, and IPYNB is your interactive Python notebook. So what we're working on here today is an IPYNB. So that will only work when you're using Jupyter Notebooks. However, you can export the copy. Let's see, save, download. You could download it as a Python script, and that way you'd be able to run it just using standard Python from the command line. So they're the two ways that you can save this Jupyter Notebook. For now, we'll just say everything in the Jupyter Notebook itself, because it's for beginners, it's actually a really good way of running Python. All right, so let's do our first cell. I'm going to press Shift Enter. And the very first time you can see it's got to connect. So Google are setting up an area on one of their in the cloud for you. It's a computer that can do a whole bunch of stuff. It tells you they've got given you a bit of RAM, a bit of disk space. So they've given you up to 12 gigs of RAM and up to 100 gigs of disk space. So that's pretty generous of them. And now we've got a bit of a help here has popped up because we did the question mark here, and it tells us all the things that we can do with IPython, Interactive Python, or Jupyter Notebooks. Alright, so you can read through that at your leisure. There's other things here, like you can do question mark and a word, and that'll give you help about a particular object, or you can do question mark and a word, and that gives you even more documentation. And I'll just close that with the X there. Alright, so writing Python code is all about writing commands for the computer to follow. The only commands a computer can do are rather simple, but it can do them very quickly. So here we go. For an example, we're going to display something and we're going to use the print command. So we've put in a command here which is print, and in parentheses we put the number 5. So if we run this cell, you can see it's printed to the screen the value 5. Now that will work in both Python and Interactive Python, but in Interactive Python there is another option for you, and that's you don't even have to put the print statement, you just have to have an expression there and it will display the result for you. So if we put the number 4 there and display the result, we can see it just comes up as 4. So in a cell you can have more than one command and it will just execute them sequentially. So you can see here print 4, then print 3. So it'll run the two commands. It runs print 4 first, and then it runs print 3. And so you can see print 4 got displayed, and then print 3 got displayed. So remember, this is how Python works, as well as Interactive Python. And now we're going to try the same thing using the Interactive Python syntax, which is not even bothering with the print, just having two expressions here. One's going to give you a value of 2, and one's going to give us a value of 1. But unfortunately, when you do a cell, it only displays the results of the last line. So if you need more than one line of results in Interactive Python, then you either split it up into multiple cells, or you use the print function that we've used up here. Okay, so this is all about having a go at some tasks and really getting a feel for it yourself. So I'm going to set some tasks tonight. You can have a go at them, and really they're going to be simple enough that you can do it just using the stuff that you've learned tonight, and then we'll go through a solution. So you can either pause the video here, that's what I would do, have a go at the task, and then when you can't do it, then or you've successfully done it and you want to follow the video, then press play, maybe play at faster speed so you catch up to the live session, and then we'll do that. So pause now, and I'll go through the solution. Okay, in the empty cell below, write a Python program to count down from 5 to 0 on separate lines. Okay, so you can see we've done something similar here. So I've left a spare cell for you, and you can start typing some stuff in. And we want to go, let's start with print 5, 4, 3, 2, 1, 0. There we go. So we've written a little Python program here. It's 6 lines long, and it's going to count down from 5 to 0 on separate lines. So let's see if it works. We'll click on the play button. 5, 4, 3, 2, 1, 0. There we go. We've run our first Python program that we've written. So I'll be interested to hear how you went having a go at that task. If you've even if you're a little bit behind because you've paused the video, then put it in and we'll hear from you in a couple of minutes. And if you thought there's anything unusual about that, let me know, and we can go through it in more detail. All right, now I'll provide a solution for you as well. Normally I do the solution a slightly different way. So let's see if that works. So this looks a bit different to what I had. So it says solution 1 counting 5, 4, 3, 2, 1, 0, and this time it's got words rather than digits. So here are the digits and here are the words. Now for us to print words, we've had to enclose these words in quotation marks so that Python knows that they're a string of text. And we'll see later why that we have to do that. So why we can't just put in FIVE, because Python will think we're trying to do something different. So we've now looked at two different data types. In fact, we've looked at these integers here, which are just whole numbers, and we've looked at strings, which are text. Okay, as we've already gone through this. Now Python has a function called type that'll tell us the data type of any variable that we use, or any value that we use. So here we've got these letters enclosed in double quotes, and if I say what's the type of that, it tells me it's an str, which is the Python way of saying string. Similarly, if I do type of this whole number 1, 2, 3, it tells me that's an int, which is short for integers or whole numbers. So that means no fraction. You can let's try working with a number that's got a fractional part, so after a decimal point. What's the type of that? And Python calls that a float. And the reason it's called a float is because that's short for floating point, and the decimal point, the way it stores it, that decimal point can be anywhere in this number, so it sort of floats around in the number. So it stores the number, and then it stores the exponent, and the exponent says where the decimal point is. And that's a common terminology in a lot of programming languages. They'll talk about floating point numbers. Now Python can do arithmetic on these numbers using your operators. So it's got these symbols: plus, dash, asterisk, slash, double slash, percent, asterisk, asterisk. And we went through those in Getting Started 1. But they were pretty obvious, so I'll just quickly recap. So that's addition, subtraction, multiplication. This is floating point division, and this one is integer division. And of course, when you have integer division, you'll have a remainder, and you can use the percent sign to find the remainder. And double asterisk is raising something to a power. So that was a very quick recap of those operators. So let's have a look at this cell here. 1 times 2 plus 3 times 4, and that gives us 14. So if we calculate that ourselves, we can see that that's 1 times 2 is 2, 3 times 4 is 12, and 2 plus 12 equals 14. And so you can see that Python understands the order of operations. It does multiplication before addition. So you've got your standard POMDAS brackets of multiply, divide, add, subtract, and it'll do all the arithmetic in that order. We can also save the results from expressions into memory locations, and we call these memory locations variables because you can change the values that are in them. And to do that, we just use an equals sign and what the value is. So if we have the value 5 and we want to store that in a memory location, and we we give it a name A. Could be called anything. So let's say A equals 5, and then we can say print A, and that will print the value of that variable. And now you can see why we had to put quotation marks around the text before, because if we didn't put quotation marks around it, Python thinks that you're using variable names. And you use variable names more than you would use literal values. So literal values have the text, have the quotation marks around them, and variable names don't. All right. You can also assign a value of a variable to the result of an expression. So here we put in an expression, what's 2 to the power 32? And we can store that in the variable b. And there we go. So we've got another question here. Python is not strongly typed. That is correct. So any variable can store a value. You don't need to declare what type that value is. Now there is in modern versions of Python, they've got some typing facilities, and it's not a constraint. It's just a hint. It's called type hints. So for example, I could say C is an integer and run that. And so C is this number here, which is an integer. But if I said C was a float, at that stage, it's really just a hint. So even though I've said C is a float, it's still only stored it as an integer, and I can tell that because there's no decimal point there. And the reason the hints are there, and they're really useful when you're using a integrated development environment like PyCharm, is it'll go through all your code and tell you if you're using incompatible variable types. But in Jupyter Notebooks, they're not much help, so we'll just leave them out for now. And it's really quite flexible to be able to put any data type into a variable. Okay, programming would be very cumbersome if we had to type a line for every command we wanted to execute. So it's great if we've got another question, so we'll answer this one first. Print 2 plus 2. Well, that's a good thing to try. So let's enter in a code cell here and see what happens. So we've got a string 2 and an integer 2. Now I predict that Python's not going to know what to do with that because it doesn't make sense to it. What does adding a number 2 to a string 2 mean? And let's see. Yep, it throws up a type error. So you can only concatenate string to string. So you have to have 2 strings there. So I've got a couple of things that we can do here. We can convert an integer to a string like that, and that will give us 2. Or we can convert our string to an integer. And you see here I'm just using the type name as a function on the value of a different type, and it converts it. So there we go, we get 4. So you can see there's a different answer based on whether you decide you need to convert both of them to strings or both of them to integers. Now when we say we can't do addition, you might be surprised to find that we can do multiplication. So if I do 2 times 5, what do I get? And I get 5 2s. So that's a really quick way of producing a repeating string. And that's really the string 2 plus the string 2 plus the string 2 plus the string 2 5 times, which is what you'd expect times 5 to do. And it doesn't have to be a single character. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, let's go on to loops. So loops is how you repeat commands without having to type the command many times. So we remember before we had to write print and for each number that we wanted, and so that was quite a lot of typing. So loops can start with a while or for keyword, and we're going to look at the for one now. So for loop in Python, you say for, and then you give it a variable name, and every time through the loop, that variable name will have a different value from a collection of values. And so we've got a collection of values here. We've put our values all in parentheses, so that makes it a data type called a tuple or tuple. You can also use a list if you use square brackets, so you'll see that quite often. And it'll go through the loop every time Z. So the first time through the loop, Z will have the value 5, then 4, then 3, then 2, then 1. All right. Now, how does Python know what's in the loop and what's not in the loop? And this is where Python's a bit different to other programming languages, is that it does it by working out, by looking at the indentation. So indentation is really important in Python. So here I've indented 4 spaces. I think by default Google Colab indents by 2 spaces when you press tab, and that will work as well. But I've just made this more consistent with traditional Python, which uses 4 spaces. I mean, traditional Python will work with 2 spaces as well. You just have to be consistent how many spaces you're using, and make sure that they all line up. So these 2 commands are in what they call the code block, and the code block starts with a colon on the previous line. And so they're the lines that will get repeated, and then this line is not indented, so that's the first line that's not in the loop. So let's run it and see what we get. So we've the first time through it's printed 5, then the second time through it's printed 4, then 3, then 2, then 1, then 0. So it's gone through the 6 times through the loop. It's run this command here, total plus equals Z, where total started off as 0, which means add the value of Z to the total. And so the last time we've come through the loop, we can say the total of all the numbers is 15. And if you add those numbers, you'll see that that's correct. All right, task 2, rewrite the loop to show a running total as it loops through the numbers. Okay, what have I... Oh yes, so up here we've used a print command to print several values, so we know how to do that. All right, so pause the video if you want to have a go at this by yourself. If not, I'll just watch along and then run it, or even try to type as I'm typing. Okay, so I'm just going to copy all that code. And the only change we want to make is show the running total. So I can just put a comma in here and include our running total variable. And it'll go 5, running total 5, 4, running total 9, 3, running total 12, 14, 15, 15. So that's good. That gives us an extra check actually that our running total is working. All right, let's have a look at the solution. Okay, so the solution here, we're going to show how to do the same problem using a while loop rather than a for loop. So a while loop works by having a conditional statement, a conditional expression really, that if that turns out to be true, then it will do the loop, and it'll keep doing that loop while that's true. So you'd want to make sure there's something in this loop that's going to change the value of that conditional expression, otherwise you're going to have an infinite loop. It's just going to keep looping forever. So if we look quickly down here, yep, we've got here changing Z value, we're subtracting 1 from z. So z starting off as 5, and then we're subtracting 1 from it, and it's going to eventually get down to 0, in which case it'll drop out of the loop. So this is quite a good way of doing it. It's a little bit more code in this situation, but if you wanted to do this loop, say for 100 numbers, it's easier to do this than to type 100 numbers in our list or tuple up here, our sequence of numbers that we're using in our for loop. So remember, we're just trying to do the Python with the stuff that we've learnt already, although we hadn't learned while loops, but now we know while loops. We can see how that is. Our print statement's been a little bit more expressive. So the number is 5 and the running total, so that makes it a bit clearer which is which. And z keeps subtracting 1 until it got to -1, and when it was -1, then it just jumped out of the loop and continued on. There's nothing else to do, so it just stopped. Alright, write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. Okay, so let's see. We'll start off with our factorial as 1. So I'll have a variable named factorial, and I want to go up from 1 to 5. So I find for loops are very easy, and I'll use square brackets this time. 1, 2, 3, 4, 5. And remember to put a colon at the end. You see, when I put a colon there, if I press enter, it's automatically indented. So it might be automatically indented 2 spaces for you, but it's automatically indented 4 because I've told Google Colab I want to use 4 spaces, and it's waiting for the next thing. So my next thing I want to do is I want to times equals that, so multiply it by I, whatever it was, multiply by I, and then I'll print the result. So we'll say factorial of I is factorial. Alright, factorial of 1 is 1, 2 is 2, 3 is 6, 4 is 24, 5 is 120. So that looks good. Let's have a look at the solution. Solution is actually going to go all the way up to 20. And remember I said before, that gets a bit tedious having to write a whole bunch of numbers up there. So Python provides a function, a built-in function called range, which will go up to, but not including the final value. And the not including is a trap for young players. So it's yeah, you'll see that. All right, we have another question here. Is recursion allowed? Yes, recursion is allowed. So if you're writing a function, we haven't got onto functions, writing our own functions yet, but if you're writing your own function, you can call it yourself from within the function. So yes, in factorial function, if you're writing that function yourself, that's a common way of writing it, is factorial of n equals n times the factorial of n minus 1. So if you want to write your own functions, it's just def is the name of the function. It's the keyword to say I'm defining a function. You put in there what your n value is, and n is greater than 0. Return n times factorial n minus 1, and that's probably just greater than 1, else return 1, print factorial of 5. So this is a bit ahead of what we really need to do, but it's seeing you're interested. We'll just have a look. So factorial of 5 is 120, which is the same answer we got from here. So that's how you would write a recursive function. Okay. Oh yeah, so the range function here, that goes from 1 to 20, starting at 1 and going up to but not including 20, and the factorial. So let's run this, and we'll see 1 factorial 5 is 120 like we found before, and factorial 19, you see 19 is the last one that we've got there in our range. And the reason they do that is it's really useful. If you subtract the beginning number from the end number, you'll get how many loops you're going to be. So 20 minus 1 is 19, and that's what you get, 19 loops. All right, thanks Gupta 51. All right, task 4, display the first 20 numbers in the Fibonacci sequence. So Fibonacci the sequence looks like this. So it starts with 1, 1, and then every number following that is just the sum of the two previous numbers. So how are we going to write that? So let's have a couple of variables. Maybe we'll need 3. So we'll call them F1, F2, and F3. So we'll have F1 here, F2, F3. And so F3 is just going to be F1 plus F2. So let's start. F1 equals 1, F2 equals 1, and we're going to have F3 equals F1 plus F2. All right, so once we've got F3 being F1 plus F2, then we need to change F1 to be this one and F2 to be that one, and we calculate the new F3. So the second time we do it, we say, okay, so F1 equals what the old F2 was, F2 equals the old F3, and F3 equals F1 plus F2. So let's print these out just to see how we're going. And we got, so 1, 2, 3, we're up to this part of the Fibonacci sequence. So let's put another print statement up in here so we can see how it started. So it started 1, 1, 2, then 1, 2, 3. All right, and then 2, 3, 5. Okay, so every time we've got F1, F2, and then F3 is just the continuing on of the Fibonacci sequence. So really, if we want to do that, we can see that there's a loop going on here. And we want the first 20 numbers. Well, we know the first two numbers are 1 and 1. So let's print F2 and print F1. And we don't need F1 and F2 anymore. We're just really interested in the F3s. So there we go, 1, 1, 2, 3, 5. So our Fibonacci sequence is looking pretty good. So can you see how we can put this into a loop? And if we look here, we see there's some repeated code. In fact, let's start repeating from there. and we just have to do that 18 times because we've already got the first two numbers. So I in range 18, and then we just indent what we want to be in the loop. So I just pressed tab then. I selected the lines and pressed tab, and Google Colab indented them all for me. And there's our Fibonacci sequence, our first 20 numbers. So we get 6, 7, 6, 5 as the last one. Alright, so let's have a look at the solution to this. Now this is looking a bit different to what we did. We've got a range 18, so that's looking good. There's quite a few less lines of code here. I'm just going to clear this output so we can compare the two. So we've got a loop here for underscore in range 18. This is possibly not something you need to learn in your first beginner's class in Python, but you can call variables anything including just a straight underscore, and the reason you use underscore is basically you say I'm storing this number, I'm using a variable, but I'm never going to use it as to know what the value is. I just really want to have a loop here that goes around 18 times. So you're telling other coders who are looking at your code, I'm storing it here, but it's not an important number, so I'm just calling the variable underscore. So you'll see that occasionally in code. All right, but let's have a look at this line. F1, F2 equals 1, 1. So that's really taken these two lines, F1 equals 1 and F2 equals 1, and put them onto one line, which is a clever thing that Python can do. So you put all the variables that you're wanting to assign values to on the left, then an equal sign, then all the values that you want to assign to those variables on the right, and you just separate both sides by commas. So the first one here goes to the first variable, the second value goes to the second variable. So that's pretty handy to be able to do two values at once. But if we look down here, we can see that it's really handy because it means we don't even need an F3, because we need to swap them around. So we want F1 to become what F2 was, and F2 to now become F1 plus F2. So by doing that, it means up here we needed 3 variables because we needed to store this third value before we could start assigning these other 2 values around. Otherwise, if we started doing these assigning these too early, we'd lose one of our values, one of our previous values. But by putting them on the line at the same time, it memorizes them all on the right and then assigns them on the left. And so we've saved another variable name by doing that. And then we print F1 and F2. Oh yeah, here we go. So here's our print statement. So we're going to print our F1s until we finish. And then we've got inside the print statement another parameter saying, rather than end with a new line, end with a space. And that means that all our results will come on one line. So here's our Fibonacci sequence, all coming out on one line. We get the same final answer we did from running this cell of 6765, but we didn't get new lines after each one, so the results are in a much more manageable form. And then after the last one, we wanted a new line, so we used just a straight print statement there without the end equals space. All right, task 5, count down in steps of 2.25 from 10.5 to -3 inclusive. All right, so how are we going to do that? So you can see in our 4 statements, when we use the range, if I do a help on range, it tells me that the arguments, the start, stop, and step, but it's just a sequence of integers. I can't use floating point numbers there. So if I tried to say for I in range So we want to go count down in steps of 2.25 from 10.5. So if I said I want to go from 10.5 to -3, and because, so we'll go 2.9, and we go down in steps of 2.25. So do we think that's going to work? And no, we can't put float objects into the range function. So maybe we should use, we could type the numbers out, but then that's defeating some of the purpose. So maybe we can use a while loop for this. So we'll start at 10.5. We'll have our step down equals minus 2.25, and the limit equals -3. So while n is greater than or equal to our limit, I'll use a different variable name this time, print n, and then our step. So I've got a negative step, so I'll do plus equals here. N. Oh yeah, we've got to set n to our starting value. And there we go, 10.5, 8.25, all the way down to -3. So did anyone manage to work that one out that way, or did they work out a different way of doing it? All right, let's have a look at the solution. So the solution is going to use a for loop, and it's going to use the range function. So the way it's done that is converted everything to integers by finding the lowest common denominator of our numbers. So we've got 10.5 is the same as 21 on 2, -3 is the same as -3 on 1, and step of -9 of -2.25 is the same as -9 on 4, so the lowest common denominator is 4. So we'll say lowest common denominator is 4, and we'll multiply everything by that, and then when we print the results we'll divide by it. So that gives us our start, our stop, and our step. And just looking on the numerators, and that worked as well. Now in the output here I'm going to show you a thing called format strings. So a format string is a string, so here's a string, it's enclosed in double quotes, but it's got this letter F out the front, so F says it's a format string. And then anything inside it we can put in just some text there, and any of that will just get displayed as per normal, see, calc, but you can then put these curly braces inside the format string, and anything inside the curly braces will be evaluated as an expression. So here we have an expression. So we've got a colon here. On anything to the left of the colon is our expression to be evaluated. Anything to the right of the colon is how we want it formatted. So we want x, which is our integer, all in numerators, and we want to divide that by the lowest common denominator to create a real number. And then, so that's going to be a floating point number, and we want to display that. We want it displayed 7 characters wide with a decimal point and 2 decimal places, and we're just telling it that it's a floating point number. And here we go. There's your 7 characters just up to there. We've also got another space in there, which is that one there. We've got a decimal point. There's decimal points in all of them, and we've got 2 decimal places. So you can see here our results vary between 1 and 2 decimal places, but here it's all 2 decimal places, and we want, like, we could say give us 3 decimal places, and once again it all stays nicely lined up. So these format strings are a really powerful way of formatting your results. I've done them to make it look better, but it can make your strings, your print statements, look a little bit more complicated, but you just break them down to the parts and you should be able to understand them. Okay, so make sure you ask me any questions if you're having trouble with any of this. All right, so floating point numbers. Now there's a problem when you're using floating point steps, because when the denominator is not a power of 2, floating point numbers can't be exactly represented by a binary number and that's common with a lot of programming languages, and Python is similar. So for example, if we have x equals 1.0 and we keep reducing x by 0.1, we'd expect to see 1, 0.9, 0.8, 0.7, 0.6. But let's see what we get. We get 1, 0.9, 0.8, 0.7, but then it's 0.7, 1, and that's because this 0.1 is not an exact number, and so there's been some rounding errors that have just been accumulating, and they get bigger and bigger and bigger until this number should be 0, but it's actually 1 by 10 to the minus 16. So it's still pretty close to 0. If you use formatted strings, you wouldn't see any problem, but this is a problem in any programming language that uses a binary way of storing floating point numbers. So if you don't want these errors to accumulate, then your best bet is to use integer arguments and then divide by a denominator. I've got a question here. So this is obviously about format strings. 7 digits includes decimal. That's correct. It's 7 characters wide, so that includes spaces at the beginning, all the digits, and it includes the decimal. So yeah, if you know you've got 20 characters of space, then you'd say 20 and then 0.3, or how many decimal places you wanted in that. Yeah, there's things that you can also do here, like you can put in, so you want the values to be, currently they're space padded, but you can have them 0 padded and right justified, and you can see it's put zeros in front of them all, so 008.25. It doesn't look so good for negative numbers, but you know, maybe we can do something like can't put no, I was trying to be clever there, and there we go. We've hash padded all the numbers, so that will work as well. All right, where are we up to? Oh yeah, so this is avoiding accumulating that error, because it just keeps getting worse and worse and worse, because we keep doing the same function, the same operation that's got an error in it every time we do it, so the error just keeps getting bigger and bigger. So one way is to use integers all the way through, because we know there's no error then, and then only divide right at the end, and then that works as a good way of doing it. Yes, and there's other ways, like there's the NumPy library, which allows you to use a range type function, but even that has similar problems. All right, so let's look at another data type. We're going to look at lists. So we looked at tuples before, and lists are very similar. So lists use square brackets. We did do lists, so this is really just a quick recap. Oh yeah, so we're going to learn how to create lists now. So this is one way of creating the list. You just put all the values, separate them by commas, and put square brackets around them. Now you could do the same thing in a loop if you wanted a lot of values in your list. So for example, for x in range 30, so that's going to be 30 values going to go in the list, and I want to put 2 times x there, so it's going to be the same thing, 0, 2, 4, all the way up to, well, it's going to stop before 60, so 58. 56, 58, and there's the last value. So you can see what we've done here. We've created an empty list, which is just the 2 square brackets. We've got our list. We looked at what's indented, so that's the code block that's going to be repeated. We say mylist.append a value. So we take x, we multiply it by 2, and we put that value into the list. So 2 times 0 is 0, that goes into the list. Next time through, 2 times 1 is 2, that goes into the list. So there we get 4, then 6, then 8. They all get put into the list, and then we can print the list as it's all been accumulated. Alright, so task 6, create a list of numbers from 20 to 0, stepping down by 4 each time. Alright, so we'll go my list. So when you're creating lists, this is one of the tricky ones to find a name for it, because you don't want to call it list, your variable list, because if you call your variable list, then you will override the built-in list function and data type, and then you won't be able to use the built-in function anymore. So it's a bit scary how easy it is to override the built-in functions. So come up with a name that's not one of the built-in functions, and not one of the keywords. Python likes to have variable names using this when you've got more than one word. It uses the convention, it's just a convention, but is to use underscores between the words and do all the variable letters in lowercase. Alright, and we create our empty list. C is a good enough variable name. I just mistyped it, but that'll do. And we're going to start from 20. We're going to go down to 0, but we want to include 0, so our stop is going to be -1, and we're going to go steps of -1. -4, in fact, -4. Append C, and then let's print the list to see if we got it right. Okay, so there we go, 20, 16, 12, 8, 4, 0. So that's correct. It's gone from 20 to 0, stepping down by 4. All right, we have another question here. It's great to get all these questions. List assumes starting index is 0. Well, that's true. Python does have a starting index of 0. We haven't actually come across that yet because we haven't had to refer to any of the values in the list. The 0 that came in here, that's because range starts with a 0. So if you remember the starting value here, start defaults to 0. So that's where that first 0 is coming from. But to answer your direct question about indexing, so let's look at my list 0, and that gives us 20. So the first index of the first value is 0, index of the second value is 1, so 16, 2. So to use an index on a list, you use these square brackets again. All right, let's have a look at solution 6, using the list constructor, which can take any iterable value. All right, Well, that was a quick way of writing the code. So I've written the code here for C in range. I had to create a loop, and then I've appended the value one at a time. But the list constructor, which is just list and then parentheses, can take something that you can iterate over, and range is something you can iterate over, and create a list from it automatically. So that saved a few lines of code there. It's really those 3 lines there got compressed into 1 line. Alright, okay, so task 7, we know about this new way of creating lists. Create a list of the square numbers from 0 squared to 10 squared. Alright. Nope, I can't think how to do that. Arrange is linear, and we're looking for a quadratic function there. So we're going to go back to our old way of doing it. So problem with L is they look like a 1. So let's maybe LST. Here's an empty list for X in range, and we want to go from 0 to 10, so there's 11 numbers. So we'll say 0 up to but not including 11. List dot append X squared print list. Okay, so that worked, 0, 1, 4, 9. I couldn't think of any other way of doing it with what we've learnt so far. So let's have a look at the solution. The solution's got this clever notation here, which is called list comprehension, which is a nice thing you find in Python for creating lists, because they worked out that people were doing these 3 lines of code quite commonly. And so they said, how can we abbreviate that down to 1 line just to make it a lot quicker for people to create their lists. And so here, this is what they've done. So you've got your square brackets here. That says we're creating a list. So this will actually work with tuples as well. If you had parentheses there instead of square brackets, you'll be doing tuple comprehension. But I'll just teach you with list comprehension for now. All right. Then we have our for loop. Better do it in order. Our for loop here gets put at the back here. We've used a different variable name, I rather than x, but we could have used x here. And then what we want to append is the first part of our list comprehension. So let's run that, see if it works, and sure enough, we get our square values, and we did that in 1 line of code rather than 3 lines. Now we've got a question here, mylist -1. This is a fun thing that you can do with Python lists. So let's have a look, and this is where I just love interactive Python and Jupyter Notebooks, is you can just type stuff in and see what happens. So let's go list index -1, and it's 100, so it's giving us that value there. So let's see, -2 is 81. So you can see that if you put in a negative number for a list index, it will start counting from the back. So you go -1, -2, -3, -4, or if it's a positive number or 0, it'll start from the front. So 0, 1, 2, 3, 4. So it's a really good way. If you say, give me the second last number in a list, that's just list -2. In other languages, you have to say, give me the index is the length of the list -2. But in Python, they just go, okay, well, we've got all these negative numbers, but why not just use them? Okay, task 8. Create a list of tuples, which is going to be I and I squared for I from 0 to 10. Okay, so we open a list. really, it's just about as good as this. We want a tuple with an I and an I squared for I from 0 to 10. Okay, so in Python we type that as in range 11. And there they are. In our list we can have many different data types. They don't even have to be all the same data type. We've put them all here. We've got all tuples, and each tuple has got 2 values in it. Really, the difference between tuples and lists is tuples are a read-only version of list. So unless you need the ability to add new values to the list or change the value at index 3 in the list, if you don't need to make any of those sorts of changes, then use tuples, because you actually find it'll be a lot safer in your code, and you'll avoid some of the errors that will come up with what are called mutable values that can be changed. But that's more of an advanced topic, so I'll leave it for now. All right, now I've done list comprehension here. I haven't stored it in a variable. It's just so it's interactive Python has just displayed the value of that expression. So let's have a look at the solution. The solution is identical, but it's stored it in a value and printed that. So when you use the print command, it uses a different format for printing rather than the interactive Python way of displaying the result. But it's got the same results there. Okay. Conditionals in Python use if, else if, and else. So we had, when we did the factorial before, remember, we did an if and an else. And once again, these use the concept of code blocks. And so there's a colon at the end of the line, and then we indent again for anything that's in this code block linked to that colon. And this colon here is linked to this code block, and this colon is linked to this code block. So in this case, we're going to use modulo to determine if a value is divisible by 3. So so modulo gives us the remainder. If the remainder is 0, then it is divisible by 3. If the remainder is 1, then we know that the value is 1 more than a multiple of 3. And if the only other option it could be is 2, then we know it's 1 less than a multiple of 3. Let's run that. And that's 0 divisible by 3, 1 more, 1 less. So it got all the numbers correct. Now we've got a question here. So this is a pretty fancy question. Can tuples be used as key value pair? Right, so sometimes you'll want to use a list of tuples where you can have duplicates of the keys. In this case, we don't have duplicates of the keys. So let's write some code up here. The data type you use then is a dictionary, so it's called DICT, and they do key value pairs, so it's very similar to a JSON object in JavaScript. But so let's have a look at a couple of the differences. I'll just quickly go over what a dictionary is. So we can create a new dictionary like that, DICT, or just like lists have got square brackets, dictionaries use curly brackets, and that's the same as JSON objects use curly brackets. So in this case, we could say I want 1 to be 1. So we'll have an index of 10. It gives us 10. And 100 gives us 100. Okay, so let's have a look at that. That gives us a dictionary, and it's just a bunch of key value pairs. and that means you can refer to any one of them. So you can say, tell me what dict, and now the index that you put in here is the key of your key value pair. So dict of 100 is 100. So we've retrieved the string. Now what's different about these dictionaries and JSON objects is our keys can be lots of different data types. We've used integers here. You can also use so let's create a new thing. We can use strings, and you see at the end our last one, the key is 4, and we've used the digit at the value as 4. Yeah, we've got another question here. Can tuples contain different var types? That is correct. Yep, you can have a whole bunch of different var types in one tuple. And really just play around and see what you can do. So you can even use a tuple. So I'm going to have a tuple here, which is going to be 0 and a different var type. I'm going to do 0 equals, and the value, we'll call it zeros. So let's have a look what dictionary looks like now. And there we go. It's we've set the value of 00 and it's equal to zeros, and so now here our key is that, because that's what's left of the colon, and our value is zeros. And what surprised me about that was that it actually put this at the beginning, and I was pretty sure with Python 3.6 and later that the dictionary order was going to keep appending them to the end. But anyway, it's very interesting. So if I want to look up that value, I can just put in my key, and my key can be my tuple. So I look that up and it'll say zeros. So you know, a sort of place that you would use tuples as keys for a dictionary is if you've got like XY coordinates and you just want to store one value in each XY coordinate. So I did that. I've written some code for teaching children how to program in Python called Pythonator, and that code I need build stuff in a Minecraft type world called Minetest, and so I just needed an XYZ coordinates and what they're going to build in there. So I'd have, you know, 1, 2, 3, I want a block of stone, and 1, 2, 4, I want a block of wood. Alright, so how are we going? We've got a few things to do. Alright, we'll race through these. Create a list of numbers from 20 to 0, stepping down by 4 each time, excluding numbers divisible by 3. Alright, so we would like to use list comprehension, but we've got this extra condition in here, excluding numbers divisible by 3. So what's that going to look like? We're going to create a list, so I'll say list equals that. We'll just use the normal technique of a loop for I in range. So we'll go from 20 to -1, stepping down in -4s. Then we use our if statement. If I %3 equals 0. So if it doesn't equal 0, so we're excluding numbers divisible by 3, then we append it, and we append I. Okay, print list. Oh, I could have just said list there. Alright, so that's left out 12 and 0, which is what we wanted, because they're divisible by 3. So let's have a look at the solution. So the solutions use list comprehension again, and because this format is also a common format that people are wanting, the if statement here, they said, okay, we'll allow you to put an if statement in, and so that can be at the end of your list comprehension. Okay, so we've got dict is like a two-dimensional array. Okay, I wouldn't really say that. You could use it. Well, it's a sparse array if you're going to say that. If you're going to use tuples as your keys here, so it's just populating a two-dimensional sparse array in the spots that have actually got value. But if you've got a well-populated array, then you wouldn't do it like that. What you would use a list of lists, and so in that case you're going to get so you'd have a list there, and then inside the list you could have other lists. That's right. And then if you want to refer to anything in that, you use your indices. So you say, I want to refer to this cell here, so that's in index 2, and I want to refer to the last number in that. So I could do index -1. So you see here I've got square brackets, open and close square brackets, and put the number 2 in there, then open and close square brackets and put -1 in there, and that should give me 7, and 7 it does. So that's really a two-dimensional array. If you are using, if you've got big arrays of data like this, then you might want to use a third-party library like Pandas that handles large amounts of data, and you can refer to, and it actually uses square brackets like this, but it allows you to put 2 values in the one set of square brackets by a row and column. But list isn't allowing us to do that. You can only put in a single index in each of your square brackets. Solution 9, we haven't run that yet, but yep, there's the results, so that's good. And we've got one more thing we're going to do. Oh yes, is we're going to storing objects in variables. So remember, we've been storing other values. Range is a function that takes these values, and we can iterate over it. Well, we can store that in a variable. So for example, r equals range, and then print what r is, and r is range 3, 14, 4. So when you've got your range stored in the variable r, you can do things like create a list from it, and there it is, and you can keep creating new lists out of that range. Alright, so here we go. Rewrite the following code using nested loops, and the code is looking at different values of range functions and printing it's printing them all on the same line. So we've used this end equals space so that they can print on one line. And down the bottom here, we're starting to store the range objects in variable names and then just using that variable name. Alright, so let's run it and see what the output looks like. So we've got, with just one value, it assumes a start of 0 and goes 0, 1, 2, 3 up to but not including the final value. With 2 value, we have a start value and a stop value, so 2, 3, 4. So it goes up to but not including 5. 3 values, we have a start, a stop, and a step. So it goes 3, 7, 11, but doesn't get to 14. And if the second value is less than the first value, you need to have a negative step. And you can see here what happens if you don't. The range doesn't print anything. Alright, so our challenge is to rewrite the following code using nested loops. Alright, so what we need is a whole bunch of ranges. 4, 2, 5. Oh, I've got them all here. 4, 2, 5, 3, 14. And we can store those in a list. So I'll use the same list variable again. Range 4. That's just 4. I'll just copy and paste these. So you can see what I'm doing here. I can store them in variables, I can store them in a list, these ranges. And then once they're in the list, then I can do a whole bunch of stuff with them. And so I've noticed there's some repeated code here. So for R in my list, so each time through the list, R gets a new value of range. And then I just want to, this is the repeated code. Print R. Print the R, that's right. Now I want to do nested. So this for statement should also be indented. But if that for statement's indented, then the code block for it has to be indented even further. And then finally, this print here is common. It has to be in the outer loop. So I have to indent that one set. And so there's my solution. And it just prints them out. You can see it's put the extra 0 in there because of it was stored in a variable, even though we just printed range 4 there. All right, so that's one way of doing that code. Let's have a look at the solution. So the solution saw, repetition here, we're putting range, we're putting range, we're putting range. Why don't we just store the arguments to range in lists, or we could have done tuples, and then we pass those arguments into range each time we want to do it. So our list here is a lot shorter than this one here. In fact, we've done, this one's a tuple of lists, just to show that you can use tuples as well as lists in this area. Then each time we run through that, the range arguments get put into our variable called range arguments, and then we want to put those arguments into range, but we don't know how many there's going to be. There could be 0, there could be 1, there could be 2, there could be 3. So Python's got this way of just saying, take your list and explode the list and just put them in the order that they appear in the list as arguments to the function. And that's using this asterisk at the beginning. This is a bit more advanced topic, but you might see it in code and you go, what does this mean? So that's why I'm showing you now. So asterisk range arguments will explode it out into the individual components and then place them like they've been passed to this function in the order that they were in the list. So for the first one, 4 is just like range 4. The second one will be 2 and 5, and we'll create a range object with 2 and 5 as the arguments. So let's run it and just see that that's exactly what we get, and we do get that. It turns out to be range 2 and 5 just by passing that list 2 and 5 into here and then exploding that list using the asterisk. All right, so that was getting a bit advanced at the end. Thank you for all the questions tonight. That was really good. I think I've answered them all. I hope you learned something. Press like on the video if you liked it. Look forward to any comments on the video or in the Slack channel. And remember, you can ask questions in Slack at any time. That was an absolute beginners session we've just done tonight. Next week, we'll be looking at a bit more advanced. We'll be looking at how to create Excel spreadsheets in Python. So we'll be collecting some data into Python and then exporting it out into an Excel spreadsheet. So I hope you'll join me next week. So at the same time, 5:30, for that